Hi. So let's look at line integrals, and the question that we have is asking us to evaluate the this integral that we have here, where c is the curve along this this vector valued function that we're given here. Then we're also given the interval from 0 to um, 0 to 1, meaning our lower limit is 0, which is this one. Then our upper limit is 1, which is that one there. So we have to evaluate this integral. Okay, so these are pretty simple and straightforward questions. We just have to remember what we do under evaluation of line integrals. Of course, this is a definite integral in this case. Okay, so what we do is that to generalize everything here, what we basically do is we need to keep in mind to say uh, if we let f to be continuous in a region containing a smooth curve c, then c can be given as it can be given in this form, which is basically this form. And to generalize it, we can say it's r of t equals to we can say x of t ti, then we say plus y of t j plus um, plus z of t k, like that. That's how we can express our c. Okay, so what we do is to evaluate this. Okay, we're going to say if we have that integral there, then let me use all the variables x, y, and z. There are some questions where you only have x and y, but let me just include z, so that if you don't have a z, just keep in mind to say there is a 0, meaning you're going to indicate it as f of xy, like that. Okay, so we say this one is just going to be equals to this one is just going to be equals to the lower limit, which I can indicate as a, then the upper limit, which I can indicate as t. So it's just more like you have the interval from a less than or equal to t less than or equal to b, like that. Okay, so what does this now what are we supposed to have here? Here you're supposed to have you're going to substitute with f of let me do this. You're going to substitute with f of xt, comma, um, you have y t there, then you have your z t there, like that. Okay, then this you're going to multiply it by the square root of, then here you can have this, you can say x prime of t, then that will be squared, plus y prime of t, that's squared, plus uh, z prime of t, this is squared, like that. Okay, so this is basically what we're going to be doing. Okay, so we just have to keep that in mind. You can actually pause the video, use this, try it out, and see if we're going to end up with the same answer. Okay, so first things first, what I'd want to do is to find my first derivatives. Okay, or to differentiate. So in this case, it's quite obvious and visible to say we are given to say our x of t. Let me write that as x of t. Our x of t is simply equals to 2t. I've just picked it from that point there. Okay, then our y of t is given as t itself. Then z of t is given as 2 minus 2t. Okay, so let me go ahead and find the derivatives. So x prime of t is just going to be equals to 2. Then y prime of t is just going to be equals to 1. Then z prime of t is to be equals to minus 2. Okay, so remember to say there is a part where you have to multiply by the square root of this squared, that squared, and that squared. So it's like you're going to add them, like that. Okay, so what it simply means is that I just have to come here, then I'm supposed to say x prime of t squared, and I've gotten what? I've gotten a 2, then I square it like that, plus I do the same for the y, which is a 1, I square it like that, plus I do the same for the z, which is minus 2 squared. What do we end up with? What we end up with, that's going to be a 4, that would be a 4, then this here to give us a 1, so that 4 plus 1 plus 4, that gives us a 9. We end up with a what? With a 3. Okay, so it simply means to evaluate this. Okay, we're evaluating from 0 to 1. I'm just using this interval that I'm given there, evaluating from 0 to 1. Then we are going to say f of xt, uh, f of xt, let me just say f of x, y, z, but in terms of t. Remember to say here I have ds, but I want to use t, so that is going to change to dt. So where there's x here, we're just supposed to substitute with what your x is, which is that one. So this is your 2t multiplied by your y, which is t in this case. Then we say plus your y, which is t again, plus your z, which is your 2 minus 2t, then that becomes dt. But before I do that, remember to say you are supposed to multiply by the square root of uh, this squared plus this squared plus that squared, of which we have found that is what is a 3. So, and actually since it's a constant, I just have to put it outside here. So then I'll put my dt there like that. Okay, so from here I believe it's pretty straightforward. Okay, it's just a matter of integrating here. So here we have we are integrating from 0 to 1. The integrand that we are going to have here, you have like your 2t squared, then that would be minus t plus 2. That minus is coming from, we have positive t and minus 2t there like that. So we say dt. So this is just going to be equals to the 3 outside. So integrate what you have there. This is going to be 2 over 3 t to the third minus t squared over 2 plus 2t. Okay, evaluating from 0 to 1. Then let's see what we're going to end up with. So this will be equals to 3 here. So if you substitute with the upper limit, which is a 1, here it will just be like 2 over 3 minus 1 over 2, then plus 2 there like that. You don't have to substitute with the lower limit, because at any of these, if you substitute with 0, it's still going to be 0. So no need to worry about the lower limit. Okay, so this I believe is going to give you something like that would be like 13 over that's a 2, because initially it was going to give you 3 multiplied by 13 over 6, meaning 3 into 6 is a 2, so we say 13 over 2. So the solution here is simply 13 over 2, and that's the answer that we were looking for. So that's how we answer this question. Thank you very much for watching, and we'll catch you in the next one.